Good day, everyone. Welcome to Galaxy Talk Show. Over here, we have interesting conversations about space science, astronomy, aerodynamics, astronautics, aeronautics, and everything regarding space. Join us as we embark on this journey. My name is Nanikia Jesse, and I'm the host for today's discussion. Joining me is Mr. Charles Dazi. He is my guest for today's podcast, and our topic is on space. Mr. Charles Dazi is the technical engineer at Galaxy Aerospace Ghana. You are welcome, sir.
Thank you, Kia. It's always a pleasure to be here. And it's exciting to be part of this podcast. The very special and first one. So, yes, so a little about myself. I'm Charles. Just call me Charles. I'm the mechanical engineer here. I take care of our rocket stuff and everything space here. So, to be honest, I have a bit of knowledge about space. Just a bit. So I'll learn more from the audience as we get a few questions that will come in later. And I'm sure you ask me a lot of questions as we move on.
Sure. So talking about space, being our first topic, I'm sure our viewers are concerned. They've been hearing space almost all their lives. So what is space in a layman's term?
I'll explain space this way. Space is that line you get to just after the Earth's atmosphere.
Okay.
Right. We have a line called the Kármán line, which sort of is an agreed line that most astronomers, most space people use to determine whether they are in space or not. Right. So once you leave the face of the Earth and you are heading up into space, the atmosphere is about 60 miles. It hits about 60 miles. That's about 100 kilometers, basically. So after that section, the sun's rays, we know the sun, we'll talk about the sun one day. It's white light, right? But because of the atmosphere, the light disperses. That is why we see the sky as blue.
Okay.
I said we also have that discussion on the dispersion of lights when the sun and why the sky is blue sometimes. So once you cross that line, the atmospheric line, then you don't see a blue sky again because there's no dispersion of light due to no atmosphere in that space.
Okay.
So guess what? You'll be seeing a dark sky. Earth is blue down there, beautiful. And then probably you stretch your neck and see Mr. Moon doing a bit of rounds there as well. So that is how we or everyone basically should sort of understand where space is. That is, it comes after the atmosphere. So once there's no dispersion of lights, you are sort of in space. Some people think it's only about gravitation. So probably when you start experiencing G's, you're in space. It doesn't necessarily mean that you're in space at that moment. So when you cross that line, then you come to space. Basically, that's it.
Okay, but I'd like to find out from you, from a layman's perspective, if my grandmom in the house or any elderly person should hear about space.
Right.
It talks about vacuum.
Yes.
So let's say there is space in this office.
Okay.
There is a space in my house.
Right.
You can come and occupy.
Okay.
What differentiates that space from the space we are
right.
talking about?
You have an atmosphere, right? That is dispersing light. And we are saying that the atmosphere ends just around 60 miles, so 100 kilometers. Let's say you have that. The Earth's atmosphere is not that thick as 60 kilometers, as in it gets to that stage 60 kilometers before you start seeing the black. And then you halve it. That means getting to space becomes what? 30 kilometers. Because you just left the atmosphere. Now you are seeing the black sky, you're seeing the sun, you're seeing all that. Let's say we made it a quarter.
Okay.
That means we came to our 15 kilometers. That means I can just shoot up and I'm seeing the black and the sun and then the moon. and you feel the coldness as well. What if Earth doesn't have an atmosphere?
Okay.
What if Earth was just there's no atmosphere, nothing, just clear like that? Then it means we shouldn't have a definition for where space is, because that becomes space. You understand? So if I don't have an atmosphere, I'm in space. So in as much as I'll get a lot of backlash, I'll still stand by that, and I'll stand by my man, Mr. Neil, Mr. deGrasse, the man who made me sad some time that took Pluto out of the planets.
Okay.
And he's still alive, Neil deGrasse, the famous astrophysicist. I mean, I was like, when I was growing up, I knew about Pluto. Pluto was my favorite planet because I heard it was cute, it was very cool, and I like to feel cold and all that. I didn't understand that level of coldness. I would have been frozen to pulp. But I love that planet. And because we used to learn my very eyes major C and the night planets, Mercury and Pluto were the most favorite ones because you always remember my and the P. And then one day he said there's no Pluto. So he also said that, look, when you take out the atmosphere, you are in space.
Okay.
So take me to space is like, take me somewhere.
Sure. So that is what I'm asking.
Yeah.
Take me somewhere. I want to be in space. So space that we are talking about, is it anywhere above the Earth?
So that's why I'm explaining that scientifically, if Earth didn't have an atmosphere, right, we are in space.
We'll be in space.
But Earth has an atmosphere. And usually, convention and sometimes when something is proved or comes out, there are little nitty-gritties about it. But when a certain number of people come together and say, you know what, forget all the nitty-gritties. We want to agree that this is space. This is space. No one should talk again. This is space. We, a group of people that are scientists, that have done our research, and people are coming out with a lot of questions. We don't want those questions again. It's like the common line, all right? We say it's 60 kilometers out there. Who told you 60 kilometers? It's gaseous.
Okay.
It can change to 70. It can change to 50. It can change to 40. It can change to 100, right? But conventionally, they came together and said, look, you know what? Let's keep it at 60. Let's just keep our common line at 60, and our space will be up there. So equivalently, you start experiencing some gravitational, you feel the weightlessness, and that is where people feel like, oh, you've gone to space.
Okay. So I'm trying to understand what you're saying, and I would like to find out, is it that space occurs after the stratosphere or the ionosphere, or where the space starts from?
It starts from where all the spheres end.
So after all the spheres,
yes,
that is where space starts from. So after the atmosphere,
yes,
that is where we have space.
Space, exactly.
Okay, so space is not on this Earth.
Because we are trying to give it a convention, like as in trying to make people understand that or give it a certain convention. But personally, me sitting here, I feel that if we didn't have an atmosphere, we would be in space. So I kind of have a problem where we have to use a certain guideline to tell us that this is space. Because from where I sit, I believe we are in space.
So where does the solar system comes in space?
Okay.
Because when we talk about space, most people think of, space, we have the sun, we have the moon, we have the solar system, and that is space.
Right.
Yes. So where does the solar system comes in space?
Yes. Now, when you talk about the solar system is as a result of our sun.
Okay.
Our sun has a huge mass, so it attracts a lot of bodies. And our sun was able to attract 9 of these planets, which one has been taken out. Okay. So the sun is tugging on everybody. The sun is trying to keep everybody in orbit. The sun holds us in orbit. So it's like when you do the general relativity that was brought in by Einstein, it's like a curvature, space-time. So the sun is sort of, when you put a thin cloth and you put the sun in the middle, it's like and you put others around it. It's like it's pulling on all of them. So that's how the sun is. The sun is pulling on all of them. So that creates the solar system. So there are a billion stars out there, a billion stars, which also have attracted a lot of planets around it, a lot of bodies around them. So we have the Antares now, which is a very huge sun. So you can imagine it has a lot of planets revolving around it because it's very heavy. So the question of things tagging on things is because of space curvature. Jupiter tags on us. When we get into line with Jupiter pulls us a bit. Earth pulls us a bit. So sometimes we deorbit. And then it's like, are we always going to deorbit and then the Earth is going to fly away somewhere? That's why they say when the sun is not there, the Earth will just keep flying away and then everything goes dark after 8 minutes. So that is the solar system. The solar system is as a result of the sun. That's why they say it's solar system. The sun keeps all your bodies in check. So that is where the solar system comes in.
Okay. So I'm asking this question in regards to what we said earlier about the space being anywhere above the Earth atmosphere.
Right.
So we know the Earth is a spherical body. And being a spherical body, it has a rounded shape, if I should put it quote unquote.
Right.
Yes. And then we have other bodies surrounding the Earth.
Yes.
So that means that space can be beneath the Earth, above the Earth.
Yes, the space.
By the Earth.
Yeah.
In front of the Earth, over the Earth, wherever. Yeah. That is what space is about.
Yeah.
Yes. But to what extent does space end?
Doesn't end. I don't think you want space to end. That is why you call it space.
Okay.
It extends. It's just there. It's just there for all the bodies, all the asteroids, all the planets, all the stars, the black holes. They are all in space.
We talked about the solar system. We've spoken about a bit about the sun and all that in space. Apart from the Milky Way galaxy, which forms part of the galaxies, and then the meteors and then the asteroids and all that we know, what other things occur in space? And what other celestial bodies can be found?
Well, as you said, you mentioned a lot. Of course, there are a lot of galaxies. Andromeda, Milky Way. There are a lot of galaxies. And these galaxies have stars. Millions of stars. Right. Our Milky Way galaxy has millions of stars, even if it is small. Andromeda galaxy is very huge. Billions of stars, right? There's a lot of phenomenon in space. We see black holes happening. That is stars dying.
Okay.
Right. Every star has a life. Even our star has its life, which that is why it's informing the likes of Elon Musk to go to Mars, because per experiments, they believe the sun is going to get very hot at the time. It's going to expand. We can't stay on Earth.
Okay.
We definitely have to move a bit further away. So all these things are actually happening in space. Stars are dying, stars are forming, planets are being formed. Asteroids are running past places, and as soon as they get into your orbit, they start orbiting. Because once then, probably a body is passing and your gravitational pull works on it, it will get stuck in there and it will start running around your Earth. Unless, of course, you have the situation where it becomes like a slingshot. And that is what they use in probably you can get to the moon. You probably do a rotation or do an orbit around the Earth. You go a shorter distance on one side. That's what they call the aperture and the perigee. So the longer distance, as soon as they go closer to the Earth pulls on it, then it goes a bit further. It gets closer to the Earth, it pulls on it, and then it gains momentum as it's being pulled. And he too is going away. So as it gains momentum, it is slingshotted to maybe probably the moon or where they intend to take it to. So all the study of these things in space have led to how come we are able to get to the moon, We're able to get to Mars. All these things is as a result of the happenings and the study of how celestial bodies are working in space.
Okay.
And all that.
But
So,
I have a last question before we wrap up this particular segment. Talking about all these phenomena in the atmosphere or space,
right.
as we put it, the light hole, the black white hole,
White
the
holes,
black
black
hole,
holes,
and all that. Is it only the Earth which is affected by all these phenomena?
Definitely not. Whatever the Earth experiences, every other celestial body, which probably is closer to the Earth or within the solar system, might experience the same thing. So, if a black hole is being formed somewhere, right, and there are stars or anything close to it, it will suck it in. It sucks a lot of matter. The black holes suck a lot of matter. Okay. So, it's like the solar system. The sun is giving all the planets light energy and heat. Of course, Mercury takes them more because Mercury is closer. And Neptune will take the less because it's very, 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 very cold.
Okay. So, viewers, this is where we come to the end of the first segment. Thank you, sir, for joining us for today's segment.
It's always a pleasure. I'll tell my audience, I think our next session will be one very interesting topic. We'll be looking at why we say things fall at the same rate. Why are people confused about the fact that when you drop two objects, we scientists say it falls at the same rate? One falls faster, and that is all we know. So we'll tackle it, and then it will bring much more understanding to us.
I believe you learned something from today's episode. You know, space is vast and it has a lot to offer mankind. Hope to see you on our next episode. Till then, bye.